Well, hello again, everyone. Welcome to Unit 6 in the Precision Farming Systems course. In this unit, we're going to take a look at soil sampling. Soil sampling has been around for a long time, long before precision ag came into its being. But what you're going to see in this unit is, once again, where that GPS and technology has come into play and has been very beneficial in terms of the soil sampling aspects of things. And so that's what kind of the whole goal for this unit is to see the importance of not only see the importance of soil sampling, but how precision ag has really brought it into a mainstream thing. And it's something we see a lot more being done these days because of precision ag. So that is kind of the whole intent of this unit, and then we're going to kind of wrap up the unit at the end where you kind of see what's coming down the pipeline for soil sampling. There's some things out there already that are kind of interesting, which is going to kind of lead into some other things I think that we'll see coming into the future. So with that, we'll go ahead and get started into the unit. To kind of begin with, to kind of show you how important soil sampling is, I've got a video here I'm going to play, and this comes from the Hefty brothers. Some of you may know them. They have a TV show on RFD TV called Ag PhD. I watch it very religiously, typically Tuesday nights at 7 o'clock. That's about the few times you can find me sitting in front of a TV. It's an interesting half-hour show what they present in terms of agronomic benefits just for farmers, and these are farmers themselves. So you're listening to people of our own kind, and it's interesting to see how they've grown over the years. I've had them down to our college a couple times to speak at some conferences, some student events, and it's amazing what they have. What this video here is, this is one of their segments from one of their shows a while back. And they're going to talk about the importance of soil sampling. So with that, we're going to kick it in. Go ahead and watch this video, and then we'll pick it up here at the end. So enjoy.
This week's Farm Basics is brought to you by SatShot.com. Satellites aren't just for NASA anymore. Use the power of satellite imagery to create variable rate management zones in your fields. To reduce input costs and increase yields on your farm, go to SatShot.com.
During our Farm Basics time today, we wanted to talk a little bit about soil sampling. So if you're a non-farmer, you're probably wondering, well, how exactly do farmers do that? And what's going on out in fields? How do they know where to sample, those kinds of things? Let's talk about that a little bit.
What I think really surprises people is farmers are getting really high-tech. When you think about soil sampling, you say, oh, okay, I just go out there, stick a probe in the ground somewhere, and get the results of that, see what nutrients I've got. That's not the case. For many farmers, they are grid sampling now, where using GPS coordinates, they divide that field up into 1 acre or 2 acre plots that they're going to sample in specific spots in those areas of the grid.
The thing is, these farmers aren't just going out and pulling one core, though. They go to an area, let's say this 1 acre, and they pull a few different cores, then blend those together in that 1 acre. So it's not just one little spot. It's a little bigger area, but still, to sample 1 acre or 2 acre grids, that's a lot smaller than a whole 80-acre field.
Well, you could do the same thing. Like, let's say you're just a homeowner with a lawn, and your lawn is 20 feet by 20 feet. You could divide that lawn up and say, you know what, I'm going to take a 10 by 10 corner here, a 10 by 10 corner there, and have 4 10 by 10 areas, have 4 different spots where you're going to send in samples from.
Okay, if your lawn is that small, though, you don't need to do anything. You don't need to divide it up into grids unless you're dealing with different soil types or different topography. In other words, if you've got a low area and a high area, you want to sample those separate. If you have one type of soil here and a completely different type of soil down here or over here, then sample those separate, like Darren's talking about, having little grids. But really, if it's all flat and it's all the same soil, I don't think it's necessary in a 20 by 20 lawn.
Well, no, but you did bring up something called zone sampling that many farmers are going to. And they say, you know what, those little grids may not exactly make a lot of sense for me. Plus, it costs a lot of money when you divide up, you know, like even your 20 by 20 lawn. If you're going to do 4 samples, boy, that's kind of spendy. But maybe you say, you know what, in my lawn, I've got a hill and then I've got a low spot. Maybe I'll sample that low spot and I'll sample the hill, and I'll send in 2 samples and see if there's a big difference and manage it that way. Because after all, if you find out, oh, the hillside needs a lot more potassium, but the lower ground doesn't need any potassium, you can do that without any high technology on your lawn. You could walk around and spread some up on the hill if you knew you needed it there, but not in the low. It's the same thing for farmers. They'll look at their fields and maybe they've got a hill and a low spot, and they'll sample those two different.
And
they may even sample the
right.
side hill connecting the two and see where they need to go, because if they find out, oh, you know what, on the side hill I need some micronutrients, but the high ground and the low ground I don't need any, well, that's pretty easy. Anybody with any level of technology can just spread the side hill. That's pretty simple.
Yep, so that is what we do on our farm. We do what's called zone sampling. So we've
Well,
done
surprise, we want to keep it simple.
Yeah, we have done some grid sampling before, and that's great. And if you're a farmer and you say, boy, this zone sampling seems kind of complicated, here, I'll tell you how to do it simply. You just go out and have your field grid sampled 1 year. Then you put all the grids together that basically test the same. You now have created zones out in your field. So in an 80-acre field, if you had 1 acre grids, you have 80 different soil samples you're sending in. But if you combine those, and maybe in the end you can have 8 different zones. So sure, some of them may only be an acre or two, some of those zones. Some of them may be 12 or 15 acres. All we care about is that we want to find where soil variation really is. In other words, like in our low grounds, we've got some high pH. In our high grounds, we have some really low pH. We want to make sure we're sampling those separate. I don't really care if all that low ground is, it goes from 8.4 to 8.5 pH. That little difference doesn't matter to me. But when I have an 8.5 pH to a 5.1 pH, I sure don't want to mix those samples together. Then I have no idea what's really going on out in the field.
Well, the biggest thing for farmers is they want to do things right, because fertilizer is the biggest crop input expense for most farmers. And you think about it, you say, well, they're going to spread fertilizer on all the ground, aren't they? Not necessarily. If the soil tests show up that, hey, we've got real high fertility here, we can get by without applying any more, that's what a farmer's going to do, because it makes a lot of economic sense. The other side of that is environmental sense. When you say, wow, I've already got plenty of nutrients here to raise my crop, I don't need any more, well, why put any more on? It makes no sense for the environment, and it definitely makes no sense for the farmer's bottom line either.
Well, once again, there are many different ways that you can sample soil. Grid sampling or zone sampling works well for most farmers out there.
Well, one thing you might see if you're out soil sampling anywhere is our weed of the week. We'll show you how to take care of this tough weed later in the show.
All right, how was that? Kind of interesting, interesting take that they have there. The part I always enjoy when I watch the show, it's interesting to watch the interaction between the two brothers. Darren always has that idea of, let's take a look at that poor ground and let's focus in on that, where Brian is more of, forget about that poor producing ground, let's focus in on the good ground. It's some interesting banter that they have go back and forth, and I've always enjoyed listening to them and watching them. So to kind of get into soil sampling in terms of precision ag, here's kind of the two main goals that we're after. Is the first part is we need to collect a soil sample that is a representative sample of that part of the field, and you'll see where that part of the field comes into play here in a little bit. But the key part to this first goal is collecting that sample, collecting a representative sample, if you want to be more precise. So that's the first part. The second goal is we want to take the information from that lab result, from that lab analysis of that soil sample, and turn around and apply that information that we learned from that into making some more decisions, some management decisions. Whether it's going to cause us to take a look at what are we doing in terms of nutrient management, adding more anhydrous, adding some lime. Maybe it's going to cause us to take a look at our crop situation, or there's some other things in there that we can look at that we're going to glean from, looking at the information that we obtained from a soil sample. So, two main goals that we're looking at: collecting that good representative sample up front, and then on the back side it is taking the information from that sample, the data that was gathered, and applying that. So that's the two main goals that we're after. Now, to kind of cover some basics on soil sampling, I kind of threw this slide in a couple years ago because I had some students that just weren't quite sure, what are some basics in terms of soil sampling. So, one of the key questions is, how often should we sample a field? The general rule of thumb is you typically should sample a field at least once every 3 years. I know a few producers who really look at that data really hard, so they want to get more data, more information in hand. So I see a few farmers that actually sample a field every year, pulling that information and taking a look at that. But the general rule of thumb here in Iowa is, you want to sample a field at least once every 3 years. Nothing any longer than that. The other question that always kind of gets asked is, what time of the year should you sample? Well, the answer is you can pretty much do it any time. However, once again, kind of the rule of thumbs come into play is, if you're looking at making some decisions for your spring planting, so you're going to start planting corn coming up in the spring, well, then you should probably be taking the samples in the fall after harvest. That gives you some time to get the results back and make some decisions before planting season comes into play. The other thing as a kind of rule of thumb is you want to be consistent. So if you're going to take samples out in the fall, then the next time you should sample, you should take those out in the fall as well. So once again, so you can start putting a timeline together is how does your fertility change over time? Well, you want to make sure that your data is going to be really good representative time after time. In this case, we want to make sure that, if we sample in the fall, we're going to come back and sample again 3 years later in the fall as well. If we sample in the fall one time and the next time we do it in the spring or do it in the summer, then it's kind of hard to compare those numbers back and forth. Now, prior to precision ag or GPS coming into play, as I mentioned earlier, soil sampling is one of those things that has been around for some time. But here's kind of what we saw is, prior to having precision ag, we would take a sample of the field, and all of those samples were basically, in essence, mixed together, and what we got was just kind of a summary of what we saw for the whole field. So you'd see what is the average pH for the whole field, or what was the average nitrogen content, or the average phosphorus and potassium and organic matter, all the different tests that can be done. What we saw was just a summary, just an average for the whole field. Well, then the same thing came to the application part. If we wanted to raise the pH because maybe it was a little bit low, we put lime on the whole field. The reality is, and we've kind of seen this in precision ag, is we know we have variability in that field. And more times than not, prior to precision ag, we probably did things to that field where it didn't really need it. And it could have caused some adverse effects to that extent. So prior to GPS, we did everything and we kind of managed that whole that field as the whole field itself. So this was kind of one of the advantages when precision ag came into place, is that we were able to, start breaking that field down into smaller pieces. So when GPS was introduced, what happened was, well, we can go out and we can pull a soil sample and we could say, here was the location, here was the coordinates that sample. And the term that we always use, it's geo-referenced. So we referenced it geographically. And then the nice thing is since I know that position and I can put it into a piece of software, now I can start painting a better picture of what my fertility looks like across the field, or looking at some of the other variables that we can get from a soil test. So we started finding the variations, and what that led us to is now we can start coming up with recommendations. In essence, we can play doctor. And as you can kind of see here by the graphic in the upper left-hand corner is, I can see there's a couple areas from the soil sampling my pH was kind of low. Well, if we want to get the pH up into something that's of a normal range or that's good for crops, we're going to add some lime. So I can turn around and have the computer come up with a calculation of here's how much lime I'm going to need in that area. And that's what you can kind of see there, that lime recommendation. So the more lime is going to relate to the areas where the pH is lower. So we started finding those variations, and then we took it the next step, which is now go ahead and do those calculations for me. And what that's going to lead into is what we're going to see in the next unit, which is variable rate applications. Now I can take that lime recommendation, load it up into my applicator, and all I have to do is drive across the field, and that spreading machine, it's going to speed up and put on that rate of 3 to 4 tons per acre. And then when I get to the other parts, it's going to drop down, or I don't need it at all. It's just going to shut it off. So this is kind of where it's come full circle. So this is kind of what we're seeing in terms of what soil sampling can do and the power that goes behind it. So now we'll kind of get into some of the specifics of what we see in soil sampling. And the first thing that we want to take a look is what type of samples can we take, or what's the different types of sampling methods out there. And right now, what we see is that there's basically 4 main methods or approaches. And we'll kind of hit on each one of these here and kind of talk about the advantages, disadvantages of each. So to begin with, random is just like the name says, is that there is no defined pattern. And so what we're going to do is we're just going to walk through the field and just grab a sample wherever we feel like it. So it's a random sample. Couple things to keep in mind is if you're still going to do a random sample, is once again, you want to make sure that sample should be of an area that is under 15 acres. Some people say 10 to 15 acres. Personally, if it was me, I would say it shouldn't be more than 10 acres, or it shouldn't represent more than 10 acres. And when you get to an area and say you want to pull a sample, you should probably take out 20 to 25 cores, which means you're going to put the probe in the ground, and that's going to pull up a core. You need to do that 20 to 25 times for that one random sample. And what you're going to do is mix that up, put that in the bag, and that's what goes off to lab for that one area. And typically, if you're going to do a random, the best advice is what they say is you want to kind of go through the field in a zigzag pattern across the field. The next slide will kind of show you some images of what that looks like. So random, no defined pattern. You're just going to kind of zigzag back through the field and make sure that you're grabbing 20 to 25 cores in about a 10-acre area. So the advantage of that is it's going to be a lot cheaper. This is the cheapest method out there because there's very few samples, compared to the other types. So this is the fewest amount of samples that you're going to collect in the field. The disadvantages is where you see it's going to outweigh the advantages, is that what we're going to get is, if we're talking 10 to 15 acres, we know there's probably going to be some variability in that area. And so what we're going to see for a sample in terms of results is, once again, we're kind of getting back to that average of, even what we did prior to GPS. And the other thing is if I'm just pulling it randomly, maybe I'm going to be on the border of some other features. So maybe by soil type and some other features or the type of crop or something like that, is maybe I don't know what that is. And those things will have an effect on it. And that's gonna, affect my results as well. So, so here's kind of an example, a couple examples of some fields where we're going to take some random samples. And if you look on the left-hand side, I've kind of noticed this is, so they kind of zigzag through the field. But if you notice up there where the red spinning circle is, there's a pretty big area there that got missed completely. And we could have had some things going on that we never would have known about, and we wouldn't see those showing up with the results. Vice versa, if you look down to where the blue spinning circle is, now I have 2 points that are fairly close together. And once again, I'm probably going to see some similarities in there. I probably should have spread those points out a little bit further. So this is kind of where I'm talking about the disadvantages. And the other thing is maybe one of these points, like what I'm referencing here, is one of these points is right on the border of 2 different soil types. So I could see some different results coming in. And once again, that's going to be averaged, and it's not going to do me any good. So random is one of those, you don't see it being used quite a lot out there. It's fairly infrequent anymore. About the only time you see it is when someone wants to be really careful how they spend their money. They don't want to spend the most, so they're just going to do the bare minimum. Now, zone type of a sampling is kind of what the name says, is we're going to take that field, or we're going to take that area, and we're going to divide it up into zones. And once again, you want to try and get your zones down into something manageable. So once again, a lot of people say down into that 10 to 15 acre range, or even less than that. And what you do is each zone is kind of based on some feature. Or you're going to take a look at the field and say, maybe I'm going to create my zones based off of my soil type, as an example. So you can create your zones based off of that or some other feature. So the nice thing about this, the advantage is it's going to give us a little bit assessment of the variability. So we're going to keep things kind of consistent. So that's going to make sure that the data that we get back, the information we get back, is going to be a little bit more consistent. And obviously, it's going to be a lot better than that random type of sampling. So it is somewhat cost effective because you're going to see coming up with the grid and the modified grid that are going to be more expensive. Zone is still somewhat cost effective because maybe I'm not going to have to pull as many samples as I do with grids or modified grids. So how do you break out those zones? Well, that's kind of up to the producer to decide. What I've seen in the past is some people have based their zones off of the soil map, looking at the soil types. Some have based it off of the topography or the elevation, the lay of the ground. Some have based it off the past history. Yield maps as well as that take several years of yields and kind of come and do a multi-year analysis and base your zones off of what you see there. Another ones is looking at previous nutrient maps in terms of what did you do in terms of nitrogen or lime or things along those lines, and you create zones off of that. So how do you create those zones? It's totally up to the producer and how they want to do it. So here's kind of an example. So this is pretty much the same field, and we're going to break it up into 3 zones or 2 zones, kind of depending on what we see, whether it's in the upper left-hand corner by the soil type, sandy soil versus loam-type soil versus a muck, or we look at what was limed 5 years ago, what was never limed, or we split the fields up, what was 2 fields, now it's in one giant field. Or we're going to once again look at the drainage class, or in terms of what we did for manure application last year. Once again, there's numerous ways that you can create these zones. So zone is one of those, and you'll kind of see where the zones kind of come back with as we talk about the next type. And that's what we call grid. And this is probably the most common one that we see out there right now. And so grid is, just by the way the name says, is we're going to take that field and we're going to divide it up into equal areas. In other words, we're going to create that grid. And you kind of see that down in the bottom right-hand corner in that image there. So the advantage to this is that now we have equal areas, and it's going to provide us a really good assessment of variability. So once again, keeping them all consistent. Now we can start noticing what is the stronger parts of the field or where are some of the weaker parts of the field. So that is the biggest advantage, and this is why we see a lot of people using it. The biggest disadvantage is that it typically is going to be more expensive because we're going to have to pull more soil samples, more than what we did with random and more than what we did with zone. And the other disadvantage that we could run into is, we could have even in that grid, we could have some variability in terms of like soil type. And so once again, depending on how we pull those cores, depends on, what part of the grid did we pull them from, is where we could see some of that coming into play. So here's a prime example. If you take a look at that grid, take a look at the spinning circle, and we went out there and we pulled a soil sample from that spot. Well, I was right on 2 different soil types. So as I'm pulling those cores and I'm mixing it up in the bucket, I could be pulling from 2 different soil types, and that's going to throw off the results, or it's going to skew my results later on. Now, this is a handout I got, I'd seen a while back from, it was called Precision Farming Profitability. And they actually had in there is, some good common practices when you're out soil sampling. So here's where they kind of said, they queried people or asked questions of people that go out and do soil sampling commonly is, how do you pull your samples? This is kind of the responses they got back. Most of the common ones we see here in Iowa, they're going to go A, which is they're going to go to the center of the grid. And at that grid, in the center of that grid, or wherever they're going to stop and pull that sample, they're going to pull anywhere from 10 to 30 or 8 to 12 cores from like a 10 to 30 foot wide area from around the center part where they were at. So from that one center dot up there at the center of the grid, they're going to pull 8 to 12 cores from a 10 to 30 foot wide swath. I know of a local professional soil sampling company in our hometown right here. They tell their people to go out 50 feet and pull about 20 cores. So they kind of spread it out a little bit further. So most commonly we see a lot of people pull it from the grid center. There's some other ones where we've seen that they pull it from where the grid intersects. And then other ones are just kind of random, but that's still georeferenced. So they don't go necessarily to the center of the grid. They just go to somewhere in the grid, and when they stop there, they're going to hit a button on the GPS and lock that position in or restore that location for later reference. So when it comes to grids, the size of the grids, this is typically what we see in terms of common grid sizes. What you see in the image on the right, that is our college farm. That's one half of our college farm, and the grids you see there, I believe those were 2.5 acre grids. So each one of those squares represents about 2.5 acres there in the center. Once we get along the outside edge, we don't get that full 2.5 acres, but common sizes we see out there: 1 acre, a 2.5, 3.3, 4.4, and 10 acre grids. Here in Iowa, we don't go past 10 acres because typically a lot of soil sampling that we see here done consistently is for manure management plans, and state law, state code mandates that those samples have to be 10 acres or less. So we don't see anything over 10 acres here, and I think you would be hard pressed to find grids larger than 10 acres anywhere else as well. So that's grid sampling. Kind of one of the newer ones that we've seen come about is what's called a modified grid sampling. And this is kind of where we're going to get the best of both worlds between grid sampling and zone sampling. And you can kind of see by the image down there in the bottom right hand corner. So I break up my zone, say maybe by soil type. Well, I have an area where I have that soil type is fairly predominant. So I'm going to break that area into my typical 2.5, 5 acre, 10 acre grids, whatever that is. But then once I start getting over into some of the areas where I have some variability, then I'm going to alter. It's not necessarily going to be grids. I'm going to start turning it into zones. So we're kind of combining the two. So the advantage to this is that this is going to probably give us the best assessment of variability, because now we're kind of getting the best of both worlds. And we're taking into account several of the features, whether it's the soil type or what I did in my previous fertility program, along with just putting into the regular grids where I need it. So there's a lot of advantages to it. The biggest disadvantage is that this is going to be fairly expensive, because now I'm probably going to be pulling more samples than what I even did with grids. The other question becomes about is, well, disadvantage in terms of disadvantages, what's my zone going to be? What am I going to base it off? As well as, okay, when I go to the grid size, what size of grids am I going to use? And then it also comes down into, what is the size of the grids versus the size of the zones? And, if you take a look at here, you can see here's where my grid over on the right with the blue spinning circle, and let's say that's a 2.5 or a 5 acre grid. Well, now I have a zone area over there, and that zone is actually fairly big, and maybe I'm starting to push 10 acres. So we can, at what point do we call, is 20 acres going to be better than that 2.5 or the 10 acres, and where do we see that? And once again, you can see there's some smaller areas up there, so when I go to pull those samples, now I'm going to have more samples, which is going to increase my cost for doing that. So one of the things, and this is kind of where we're going to probably wrap up this first part of the video series, and I've kind of titled this Size Does Matter. This goes back to 1994. The University of Nebraska out at Lincoln, they did a study. And what they looked at is the soil sampling density. And so what they did is on 1 acre, they basically took the number of samples times 10. So one group basically went out, created a grid, and what they ended up averaging was about 4.2 samples per acre. So they, in that 1 acre, size of the football field, they pulled about 4.2 samples. The other group went out and they did 42 samples in that 1 acre, so 10 times as many samples. So they sent all the samples out to lab, came back, they mapped it out on a computer, and here was the result. If you look at the one on the left, that has 42 samples per acre, and the part I want you to take away from this is look at how specific and how defined that is. Then you look at the one on the right that it was at 4.2 acre or 4.2 samples per acre, and you could see not as specific, not as well defined. The parts that I liked in here, and basically what they tested was the phosphorus. They looked at how many parts per million. And what you see on the left-hand side is there was one little spot right in the center of the field where that parts per million was getting fairly high. Well, when you look at it over the right, it's not in the center. It kind of shifted towards the left side of that 1 acre. And the other part is you look up in the upper right-hand corner where our parts per million started jumping up there. And we don't necessarily see that being reflected over on the left-hand side. So this is one of those things where, yeah, if you can afford it and you can do more samples in that 1 acre, look at how more defined that's going to be. What I'm going to do is there will be a video series coming up where I'm going to kind of step you through the whole soil sampling process, from sampling through, creating the sampling points to sending it off to the lab, getting the results back, mapping it out, and making a recommendation. And you'll kind of see where that comes into play a little bit. So with that, we're going to stop this first part of this unit and look forward to visiting with you in the second one. Thanks a lot.